Okay, let's try to quickly go through a problem that's now coupled and on an incline and with some friction to it. So first thing we need to do is identify the direction that we want to be positive, assuming that this heavier object is going to cause the motion downward and drag that thing up the ramp. We're going to make that way positive. So anything that is going in the direction that my marker is moving right now is going to be the positive. All right, now we have to draw our free body diagrams, label all the forces acting on each block. All right, so we have on this block the tension of the string that would be dragging it up the ramp. We have the normal force perpendicular to the surface, and we need the normal force because we have a mu. All right, anytime we have that mu in there, we have to use the fun equation. I'm going to write that down right now so we know that we have to use that. Then I have the gravitational force, the weight of the block, and then we have friction that's going to be resisting the sliding motion up the ramp, right? And then on this block, we have M2G going down, and then we have the tension in the rope holding it up. Since this direction is positive, that's going to be the positive, that's going to be the negative, this one's going to be positive, and those are going to be negative. We also have to deal with the fact that when we tilt that axis, we get an angle that's right here, so that's where our 30 goes. And to figure out what our normal force is, since we need that here, it's going to have to be the vertical component of gravity. That is the adjacent side, so we're going to be using the cosine function to calculate the normal force value because these two have to be equal. And we have the x component, or the amount of gravity that's trying to pull the block along the ramp downward. All right, so that one's the opposite, so we're going to have to use the sine function there. All right, just from the realization that I have a mu and I'm going to have to use that mu in this equation, let's just go ahead and do that. Our goal is going to be to try to figure out what the frictional force is that's resisting this. So we're going to have to use the fact that the normal force here is going to be equal to the perpendicular component of gravity. So in that case, we're going to have mu times m1g. And since it is the adjacent side, we use the cosine function of that angle. All right. So what we end up with when we plug that in, we get a frictional force equal to, I know I have it calculated somewhere, 4.24 newtons. All right, and we get that just from doing the mass times 9.8 times the cosine of 30, and then we multiply that value by the mu. All right, so our normal force is 42.4. Multiply that by our 0.1. That's how we get that value of our frictional force. All right, so we're going to need that number to plug into one of our future equations here. All right, so now let's add up all the forces on block 1. Okay, so we have the tension to the right, we have friction to the left, and we have the x component of gravity also to the left. That imbalance is going to cause that mass to accelerate. All right, so now let's do the sum of all forces on block 2. All right, we have the weight of block 2 down, tension holding it up. So we have those imbalanced forces causing that mass to accelerate. All right, now we have to add the equations together, and we add the left sides to the left sides. What that does is cancel out those tension forces, so we're left with everything else. We have m2g minus the frictional force minus m1g sine of theta. All right, that's what the left side is, and then add the two right-hand sides. Factor out the a since it is the same value. All right, and our goal here is to solve for a. That's kind of a standard format of these equations. So we divide both sides by the total mass, and we get our acceleration. So we have m2g, which should be 98 newtons, 9.8 times 10, minus the frictional force that we had, 4.24 newtons, minus m1g sine of theta. So we have 5 times 9.8 is 49. 49 times the sine of 30, half of that. So that's 24.5 newtons, all divided by the total mass of 15 kilograms. We get an acceleration value that is 4.6 meters per second squared. All right, so that's the first thing that we solve for. The next thing we do is we plug in this acceleration back into one of our original free body equations. All right, from our two objects, pick the one that looks easier to you. I'm picking this one and moving it over here. All right, so I'm going to manipulate this for tension. So I'm going to flip these two. So that tension is going to equal m2g minus m2a. All right, so we have 98 minus 46, because it's 10 times 9.8 minus 10 times 4.6. So 98 minus 46 gives us tension equal to 52 newtons. And if you pick the other equation, you should get 52 newtons as well. That's it.